Looking at the proofs of all three formulas, starting with and for all three formulas, to prove them, this is proofs outside the Cartesian plane. They also prove some of the Cartesian plane, which I'll use some thoughts, but actually these proofs that was in the textbook outside the Cartesian plane are worthless. Okay, in all of these proofs, you're going to construct a perpendicular height to the vertex of the triangle. The trick is that when you construct the perpendicular height, it must be to a vertex and not uniform. So when you construct the perpendicular height, always construct the perpendicular height to a vertex not in the form, so corner and not in the form. So that's going to be important. Okay, so we're starting off with the proof of the area rule. Okay, so this is the proof of the area rule. Okay, and they'll always give you a diagram and they'll tell you which what you must prove specifically. I won't just say prove the area. So the typical kind of question would be something like this: prove that the area of triangle ABC is equal to a half AB sine C. Okay. Right. So I just want to move this laptop. Is equal to a half AB sine C. So in this case, the vertex in the formula is the letter C. So I'm going to have to construct a perpendicular height, okay, but it must not be 2C. So I could not do this perpendicular height over here. Okay, that will not work for this particular proof. Okay, but I can construct it to any other vertex, in other words, to A or to B. So the easiest perpendicular height to construct is going to be to A. So I'm going to construct this perpendicular height, H, you want to call that letter D. It's a right in paper, so you don't have to write it to actually construct it. All constructions are with dotted lines. Okay, right. So to prove this area rule, I'm just going to start off with your base idea that the area of a triangle is equal to half base times perpendicular height. One thing we should do straight away is label each side according to its little letters. So that's big B. So this will be little b. This will be little c. And this will be little a. Okay. And you're always going to start off by simply using the area rule that you know from primary school. That the area, so this is the actual proof. The area of triangle ABC is equal to a half base times perpendicular heights. So in this particular case, if H is my perpendicular height, and the base that goes with it is A, right? H is the perpendicular height, A is the base. So in other words, the area of triangle ABC is equal to a half your base, which is half A, and your perpendicular height, labeled H. Okay, so keep looking at where you want to get. So I've got the half, I've got the A. The problem is I need to replace H somehow with B sine C. So keep an eye on what you're trying to prove. Okay, so then I need to pick a right angle triangle which has two things in it. It has to have the letter H in the right angle triangle, but I want to get rid of sine C, so it's got to have angle C as well. And the triangle that does that is this triangle over here. Okay, I've got angle C in it, over there, and I've got perpendicular height, which I've got to get rid of, which is over there. So remember your right angle triangles, the magic word SOHCAHTOA, okay, which tells us sine is a ratio of opposite over hypotenuse. So in this green triangle, ABC over here, I'm working with angle C, H is opposite angle C, and B is opposite the right angle. So B is the hypotenuse, right? So my objective is to get rid of this H in the formula, so I'm going to do substitution. So I'm going to say but, and now I want to look up sine of H. So sine of angle C is equal to opposite over hypotenuse. You have to write all these steps. So therefore, sine of angle C is equal to what in this triangle. So I'm working in triangle. So I should maybe, you don't have to write this down, but I'm in triangle ABC. Okay, so in triangle ABC, sine C is equal to opposite of hypotenuse, which is going to be H. And hypotenuse is this little letter B over here. Is H over B. What are we trying to do? We're trying to get rid of this H over here. Okay, so I'm going to isolate H from this. So in other words, if I times both sides by B, then B sine C is equal to H. Okay, so if I call this equation 1, this up here equation 2, and I go sub 1 into 2, again, we have to show this. You have to write sub 1 into 2. So if I replace H with B sine C, okay, then I've got the area of triangle ABC. This will say the triangle ABC, yeah, remember? A is equal to a half A, and I replace H. And add half H, and replace H with B sine C. And so it's a half A B sine C. And voila, I've done what I set out to do. I've shown that the area of triangle ABC is equal to a half A B sine C. You do your construction, these areas half based on perpendicular heights. And then pick a right angle triangle that links up the letter here with the height. Use SOHCAHTOA, use sine rule, sine is opposite, and then do your substitution. All right, I want you now, and once we put this down, to try and we just press pause on this video, and I want you to try by yourself and by referring back to the previous question. I want you to try to disprove that the area of triangle PQR is equal to a half QR sine P. The one hint I'll give you is don't construct your height to P. Because P is in the formula, so our perpendicular height is not going to P or right. Okay. So it could go to Q, it could go to R. It would be easier to construct a perpendicular height to Q. Right. Press pause and go try it yourself. And then come back and watch the video. Okay. So hopefully you've tried this yourself. Okay. So I'm trying to prove the area of triangle PQR is half QR sine P. I can't construct a P, but I could construct a Q, which is going to be the easiest construction in this case. So I'm going to call that my perpendicular height. If you want to give this a name, T or something, you can. Right. So now, how do I start the proof? By using the fact, well, first of all, label the sides of the triangle. So this is little p. Don't forget to do this step. This is little q. This is little r in the big triangle. Okay, and then use the fact that the area of the triangle PQR is equal to a half base times perpendicular height. Okay, and your base in this case is, if I use h as the perpendicular height, then q is the base. So it's going to be equal to a half base is q by perpendicular height. So the area of triangle PQR is a half QH. What am I trying to prove? That the area of triangle PQR is a half QR sine P. So I've got the half Q already in that formula in this formula over here. So I've got to replace H. Somehow show that H is equal to R sine P. Yeah, and then do a substitution. So if I now go right, okay, so I need to go find a triangle, a right angle triangle, which links up H with angle P. And here's angle P, and here's H. So I must be working in this blue triangle over here. So in triangle PQT. Okay, and I'm going to use sine as opposite over hypotenuse, SOHCAHTOA. So if I label the triangle according to angle P, this is opposite. Okay, this is opposite P, and this opposite the right angle, so that's your hypotenuse in that blue triangle over there. So sine of P is equal to opposite over P over the hypotenuse. And opposite P is little h. And the hypotenuse is r. The sine of P is equal to h of r. So therefore r sine P is equal to h. Right? So let's call that equation 1. We want to call this equation 2. Okay, remember we're meeting our objective because we want to get rid of the h, because h is not in our proof. So if I start running to 2, okay, we get area of triangle PQR is equal to half Q and replace h with r sine p. Okay, and we have done what we set up to. Alright, guys, hope that made sense.